from again the geometry, the area of under a curve. Okay, you can sketch some different figure such that the size, I mean, is that it is larger and larger, and you will see, oh, this arrow will goes to 0. Okay, we know the difference of the yellow one and the red one is this one. If we put this one here, okay, for this one here, and this one here, and we do this for each interval. As you can see, if n goes to infinity, and this one, the diameter will goes to 0, and the difference will be very small, then finally you can see maybe again. Okay, you can see the highest and the lowest, the highest and lowest, the highest and lowest, the highest and lowest, the highest and lowest. So finally, if n goes to infinity, then this part will decreases to 0. Means the maximum, this area contains this region, and this curve is contained this set is contained in this region. But the difference of these two areas goes to 0. Okay. The difference of these two. In fact, the difference of these two polygonal areas stands for the area of this curve. But area of a curve is 0. Got it? How to evaluate this, the area of a curve? We can use some small rectangle to cover them. And find yes, the area of the curve definitely is smaller than the sum of the areas of the small rectangles, right?
How it's always small, how it's almost the same.
Yes.
It's always small.
Yes, if n is very large, then the maximum and the minimum are almost the same, right? And now, for n equals 12, the area of outer polygonal region minus the area of the inner polygonal region is the sum of areas of these rectangles. Okay? If we subdivide finer and finer, finer and finer, you will see the length smaller and smaller, and the difference maximum and minimum will smaller and smaller. Here, the area, yes, the difference of this number and this number equals but if n is very large, then these two numbers are almost the same. So when n equals 12, we know the difference of these two numbers cannot greater than this one. But this is still high. If n is very large, then the difference of these two numbers, this one and these two numbers will less than here. If n is larger and larger, the height can decrease to 0. So these two numbers finally goes to the same value. Goes to the same value. And the middle one will go to the same value. The area. Okay, so the continuity is very good property for a function. I think you can touch this feeling. Okay.
So if n is smaller, the lowest curve is
Yes, it's very small, and the highest person, lowest person, almost the same. So the difference of the outer one and the inner one almost zero. Because, for example, this is a 1. And here is maybe 1, a 10 to the minus 16th. This 10, suppose this is a 1. When you use n equals 12, maybe here is 10 raised to the minus 16th. But here, maybe n equals 1,000. Here, maybe smaller and smaller, smaller. Finally, the difference goes to 0. So this sum, this finite sum has a limit. OK， 对，好，所以这个连续性是很好的。如果一个函数在一个有界的 B 区间上连续，当我们做这样的有限和，会发现只要随着 n 逐渐增大，你这个样本点不管怎么取，最后会跑到相同的数值。这个值就称为是定积分，所以定积分是一个数，就像导数，导函数的导数是一个数。So derivative is a number. Definite integral is also a number if it exists. It is a number. Okay, so as you can see, integration is the reverse process of differentiation. One is difference quotient limit. Another one is product summation and limit. Okay, once we know the definition of integral, this is just a limit of finite sum. So the properties of definite integral can be read also from this definition. First, suppose f is integrable from a to b. If we times c here equals c, this is because if we have a C here, then means we have a C here. By the distributive law, we can put C here. This limit exists by limit law, C can move out. That's all. Okay, don't forget. This one means it's a sum, and the n very large, and very large. So if we times product C first, then sum up equals sum up first then times C. OK， 所以这个积分的性质呢，完全就是积分就是这个有限和，就是 n 很大的时候，你可以把这个先忽略掉。Definite integral just a limit of finite sum, so you ignore this first. You may consider n may be very large, but ignore this because n is very large. This one's almost this number. So according to the property of summation, okay. So we have this property. Similarly, two sequences, term by term, they sum up equals the sum of the two finite sums. Just associative law and the commutative law of addition. So if replace this by fxi star plus g of xi star and ignore this and suppose n sufficiently large, we have the definite integral of the sum of two functions equals the sum of the definite equation of these two. Okay? Okay, take a short break.所以所谓的定积分，就是你在高中学过的这个有限和嘛 ，sigma 的东西嘛。Just from high school, finite sum.